Hello, folks. Welcome to Rational Science, directly from Frankfurt, Germany. 2100 hours over here. And what do we do here? Well, for those of you who are new to the channel, what we do is a little bit of physics. The only site that really does physics on the internet. Everybody else does irrational explanations and a bunch of math, whatever they learned from quantum mechanics and general relativity. And what we also do here is a little bit of extinction. We're saying we're the last generation of humans on Earth. Is that possible? So we talk a little bit about extinction as well. And then at the end, I open up the floor for questions and comments that people made since last time. Okay, so here we go. Let's get started with extinction first, or topics related to extinction. And in the news, we have the following. It says the U.S. cracks down on imported goods made by Uyghurs and victims of forced labor. Talking about China. And so what it's doing, it's confiscating or not accepting, blocking, whatever you want to call it, goods made from China or coming from China. Indirectly, apparently these were Vietnamese goods, came from Vietnam, that apparently were made in China. And so the United States is cracking down on that. And what should we do? Think about that. You know, politicians do whatever they want. They can take whatever decisions they want. But it tells you something. And it tells you, at least what it tells me, is that the United States is in trouble. I mean, if the United States has to resort to these measures, it seems like desperation. It seems like they're in some kind of trouble. That's what it tells me. For example, let me contrast this with another piece of news that you'll see around there, and that's this: that in Saudi Arabia, they also are using forced labor to build things, and the United States doesn't take the same type of measures against Saudi Arabia. You know, so there's like a double standard here. It's like, you know, the Saudis can do anything they want. In fact, you had this guy Mohammed bin Salman, and apparently he killed this fellow Khashoggi at an embassy in Turkey, and he got away with it. They're never going to bring him to trial or anything, you know. And the CIA has already determined that, yeah, he knew about it. He caused that problem. He ordered the murder of this guy Khashoggi. And so the question is, why China? Is it because the United States is in trouble economically? And I hope not, because if the United States is in trouble, then we're all in trouble. Okay, like I said, you know, the United States is the last empire. There will not be a Chinese empire. And if the United States is taking these measures against the empire of China, it's because it's in a little bit of trouble. Okay, now China does have this communist regime. It controls the population. It doesn't allow other countries, among them the United States, to publish whatever they want in China. You know, it controls all the information, etc. So the United States is a little worried that it can't get in there the way it wants to, like in other countries. And at the same time, here's the Chinese catching up with the United States economically. In fact, if things continue as they are now, it is said that maybe in 4 or 5 years, China will be at the same level as the United States, economically, possibly even militarily. And so is that going to mean that we're going to have a Chinese empire? The Chinese empire is going to surpass the American empire? Or is there going to be a war before that happens? Okay, food for thought. Again, I don't want to speculate on the possibility of war, but it is a very likely possibility. All you need is a false flag to get that rolling, right? And those are very common in history. Okay? Okay, and here's another bit of information that makes you want to think about, how well the economy is in the uh, in the United States, especially. Right here it is. This is the note. Says high demand at food pantries. Okay, this is just one bit of information talking about San Jose, California. I used to live in that area. And food is getting more expensive. Hunger, that's what they said in this bit of news. Feed people that lost their jobs during the pandemic. Many still can't afford food. Is this the United States? People can't afford food in the United States? I mean, what is this? We're talking about a fourth world country here or what? At the same time, food prices are surging because of the pandemic, right? Supply problems and worker shortages. Yeah, some people apparently don't want to accept jobs that are available. I guess they're picking what jobs they want to have. It's a, you could say it's a labor market, maybe, quotations on that, because the question is whether salaries are going to go up and whether the jobs that are available are jobs that people want. Okay, but yeah, when you're starving, you typically get whatever job there is out there, and what they're saying is that they're not using this word hunger. Is there hunger, or is this people just taking advantage of the system? I mean, people accuse the government of misleading and taking advantage. Here we have the other side of the coin where people take advantage of laws or, uh, you know, economic measures that are out there. They just take advantage of that. And so we got it on both sides, right? And here's one analysis of that. It says the U.S. economy added only 235,000 jobs, the lowest gain since January. Economists were expecting 720,000 new hires, so less than half. Okay, that's what they got. And the unemployment dipped. Okay, it was in 5.4, it still dipped to 5.2, so people are not looking for jobs apparently. That's what you got to conclude from this, right? And it's not that there aren't enough jobs. There are a record high 10 million U.S. job openings. Still, 8.4 million Americans are unemployed. So it looks like everybody's just clinging to the benefits. More or less, they like the fact that they're at home collecting a paycheck. And these are some of the reasons workers aren't returning. You have COVID fears, okay? Childcare needs, okay? You have boosted unemployment benefits. People who are making a little more money now, and they say, well, I'm going to hang out a little longer, before I get a job. And then there's apparently a favorable labor market. Okay, jobs are plentiful, wages are rising, but nobody's getting them. Nobody's asking for those jobs. Okay, now all that may stop uh, when these benefits stop. Is that what it is? Too much socialism? We got to get people to work the good old capitalist way. Forced labor, you're starving, you're forced to work, that sort of thing. Okay, so keep that in mind. My issue is whether the United States is really going to come out of this economic problem, okay, this situation that was created apparently by a bug that's out there. Okay, whether there's a bug or not, in my opinion, is irrelevant. I look at what's happening, as far as what is happening to the economy. Okay, so that's what I keep my eyes on. Okay, one person says extinction is almost nothing but a prediction. Well, this is why I ask people to do Extinction 101 before they do Extinction 102. Extinction 102, human extinction. Extinction 101, mass extinction. Mass extinction only refers to the past, and that's not a prediction. You don't predict the past, except in mathematical physics, right? They predict the past all the time. They predict how the universe got started. I love that one. They predict the original seed that gave birth to the universe. And this is more or less the same thing. You don't predict the past. You don't predict mass extinction. You don't predict how the dinosaur died. You don't predict how the Permian mammal-like reptiles died. Okay, We don't do prediction. We don't predict the past. So first you got to predict the past. Then you can move on and predict the future. Okay. Please predict the past. Okay. That's what we need. So you need to tell me how animals in the past died, because we're looking at not how man is going to die. We're looking at the mechanism of a mass extinction. Okay. And then we're going to extrapolate that mechanism. Not prediction, mechanism. We're going to extrapolate the mechanism to man and say, well, can man do anything about that same mechanism that all the other animals in the past couldn't do anything about? Okay, that's the reasoning. Okay, so we're not talking about the future. We're really talking about the past. We're talking about the mechanism. When people focus on when it's going to happen, then we got a problem. We're talking about how it's going to happen. Okay, and how it's going to happen has to do with analyzing mass extinctions that already have occurred. So no, it's not a prediction. And here again, I always say do Extinction 101, which is mass extinction, before you do Extinction 102, which is human extinction, because otherwise you're going to get into that kind of problem. You think that you're predicting something when you're not. You're focusing on when it's going to happen. You say it's going to happen in the future, it's going to happen within my lifetime. Well, that's different than saying that that how it's going to happen. Okay. Another person raised says, you are right about everything except an extinction of humanity. There will be a large decline in the world population, but not an extinction. Okay, that will be reserved for the corrupt governments. The governments will go extinct. Okay, you have a communist here. Okay, the way it worked. If you read Marx, okay, and Engels, they predicted, or they wanted, really more than a prediction, they recommended, they thought it would happen, right? That sometime in the future, there would be revolutions so that workers took over power over the governments. And then from then on, it would lead to a world government where all civilized persons would finally get together and say, okay, let's have one world government, let's control it, let's the workers, the people who produce the goods, right, and out there, let them govern. And then at some point in time, we reach this point where there's anarchy. Not anarchy in the sense of, the guy with the Molotov cocktail. We're not talking about that kind of anarchy. No, we're talking about a different kind of anarchy. We're saying that the system of government, meaning no government. Okay, so it leads to no government. The train of thought that Marx had was, first we have a world government, and then that government itself realizes that there's no need for it, and it ceases to exist. Okay. Now, what I criticize today, in retrospect, I've done a lot of Marxism in my life, but what I criticize is that, Marx applied that to the 19th century, which was an age of primarily agriculture, gradually converting in those days into manufacturing. So when he analyzed all this communism stuff, he did it all in the context of manufacturing, of industry, blue collar workers. That's what I'm black. Well, no, dark blue. Sorry, I'm still blue collar. He was thinking of blue collar workers. Those were the ones who were going to take over the government because they were the ones who were producing the goods. What he didn't predict was that manufacturing was going to go away completely, almost completely. Okay, it's been replaced by services. Services is a totally different kind of economy that has nothing at all to do with manufacturing or agriculture or hunter-gathering. So we went from hunter-gathering, which we did most of our existence. We did a little bit of 10,000 years of, or a little more, a little less, of agriculture. Then we did industry, we did manufacturing, and now we've moved into services. And the issue is, what's next? Are we going to be doing services for the next gazillion years? Okay. So Marx did not predict services. And obviously, he couldn't have known that we would have invented the internet and all that stuff. Today, we don't even have regular services, like hand services. What we have is internet services. Internet services is a higher level of abstraction. We have Bitcoin, we have all these people on YouTube like me just providing a service. Okay? So think about that. All the jobs that we're creating today, or a lot of them, are internet stuff. Just very, very abstract stuff. Learning, teaching, girls showing whatever they have. Those are services today. Someone singing, great. That's a great productive economy. Okay, fella says global economic collapse is a conspiracy fueled by more conspiracy like the Great Reset. The name of the 50th annual meeting of the World Economic Forum, also abbreviated WEF. And the main topic was how to recover economically from the virus, from this COVID thing, right? We may see regional economic collapse. A total global collapse is highly unlikely. He doesn't explain why, he just has an opinion, okay? That's just economics 101. Yeah, still not saying that doesn't say anything. We don't have a mechanism. We need a mechanism to find out why it's unlikely, okay? Also, the billionaire Playboy Club will not let a total economic collapse happen. We're talking about the Illuminati here, okay? We have all these people who rule the world, the rich people, the wealthy, and they're not going to let it happen because what? Having the capability to steer economies, they would lose their control immediately in a total collapse. Okay, so yeah, if there's a total collapse, these people, the rich people of the world, they come down to your level, meaning, the grassroots level, and they're not going to let that happen. That's how many people think out there, exactly how many people think out there. So this is their notion, okay? They have all these hooded Illuminati, and they're out there, and they talk to each other, and they say, why don't we do this to the public? Why don't we do that to the public, And so this is the way they keep all the sheep within the corral, okay? And this is the notion a lot of people have. This fellow is just, essentially regurgitating what a lot of people believe out there. Okay, here, let's look at this. Put it over here. This is what this fellow was talking about. This fellow Klaus Schwab, and he's talking about this great reset after the COVID. He said it's a good thing this COVID came around because it allows us now to wipe the slate clean and start all over again. We can do climate change. We can rearrange many things that, in society and economics and politics that should have been done a long time ago. So he calls that the Great Reset. And that's what this fellow was talking about. Okay, and I like this, the fourth industrial revolution. I only heard about one, the first industrial revolution, the only one, okay? And then after that, all I saw is a collapse of manufacturing from then on. There was a big rise and then finally a collapse, which today manufacturing is a very small portion of GDP and of labor, around 15% in each category. And what does this fellow Klaus Schwab say? He says, we stand on the brink of a technological revolution. Oh my God. That will fundamentally alter the way we live, work, and relate to one another. In its scale, scope, and complexity, the transformation will be unlike anything humankind has experienced before. Okay? The first industrial revolution, what? Water and steam, okay, to power mechanized production. Okay. The second, electrical power. Okay. The third one was what? Electronics and information. And what's the fourth one? Well, the digital revolution. Internet, I guess. Okay. Characterized by a fusion of technologies that is blurring the lines between the physical, digital, and biological spheres. Mighty words of this fellow Klaus Schwab. Okay, he's been around for quite a while, and he's shaken hands with a lot of people out there in the high places. Um, these are dreamers. You might say, well, he's got power, he's got influence, he's got money. Yeah, but these are dreamers. The fact that they are Illuminati, that they uh, have an overwhelming power or influence, at least, over many politicians and economists and so on, and they themselves can, alter markets. They also can get together and say, well, why don't we do this? Why don't we do that? Yeah, they can do a lot of that stuff. Will they avoid extinction? And I'm saying there's nothing anyone can do about extinction. Extinction is guaranteed. It was guaranteed from the day that Mother Nature spawned us. This is what people can't get through their thick skulls. They think these Illuminati control something. I don't care what they control. They can control the world for all I care. They will not be able to avoid extinction because they will not be able to salvage the economy. That's the problem. No matter what they do, they can create more money. They can put money over here and put it over there. Eventually, money will have no value. And when money has no value, not if, but when money has no value, that's it for mankind, including all the Illuminati. There's nothing they can do about it. Okay? So I'm saying the economic collapse is guaranteed. Nothing you can do about it. The Illuminati can stand on their heads for all I care. They will not be able to do anything about the global economic collapse. It's a guaranteed thing that's going to come. Okay, we cannot grow forever on the planet. We cannot. Our economy cannot grow forever, especially when population is now leveling off. Okay, we're producing fewer children for the next generations, and it's been dropping since 1963. That's what now, almost 50 years. 50 years that it's been steadily dropping. It's not like it dropped and it's going to pick up. No, it's been steadily dropping the birth rate. And why is that important? Well, because people mean demand. That's what people means. Okay, you have no demand, companies close their doors, they lay off workers, and now you have less demand. And the government, all that a government can do is just fill in the blanks by creating more money. That's it. And we're going to go with this cycle until money is no more, until money has no value. Okay, so that's the argument. Okay, one person says, related a little more to extinction, he says, oh, ask a biologist what is life? What is it that makes an object alive? Aha. Okay, don't ask a biologist because they never defined the word. They never defined the term life or alive or living. They have no idea. So we had to do that, okay? Alive or living, a natural object, okay, that moves against the path of least resistance, primarily gravity, okay? Anything that can move against gravity by itself, right? Okay? Natural. We're not talking about artificial, little airplanes and so on, balloons. We're talking about a natural object, okay, that moves against gravity primarily, okay? Now, are all these other objects that, airplane can move against gravity, right? Yeah, but that's created by us. So we don't include them. That's why we use that word natural object. It's only those objects that Mother Nature creates, not those that are secondhand, made artificially by something that Mother Nature made, which is us. Okay, so that's the that's the reason for the word natural in that definition. Okay, essentially a living being has the ability to move against gravity, okay? And life is just a group of living entities, okay? Is a virus alive? No. Virus is a molecule. Is a bacterium, bacteria meaning many, alive? Yes, bacteria are alive. So we have something that's made of cells, cell being the first entity that moves against gravity, okay, primarily moves against path of least resistance. It's the first living entity, the cell. That's the unit of life. Whether it's plant or life, or animal, it doesn't matter. Cell is the unit of life. Okay, and virus is not a cell. It's not compartmentalized. It's just a big molecule. Okay, and that's all it is. And virus is an inert entity. It's not a living entity. The only time a virus really moves is inside the body. Okay? Once the virus goes into the body, it goes after the cells and it uses cell material to make copies of itself. That's the theory, whether you accept it or not. Okay, that is the theory. If you got a better theory, you'd like to hear it. Okay. Okay, another issue related to this COVID thingy. Okay, I disagree, Bill. There have been safe and inexpensive cures out there, tried and trusted, talking about how to cure COVID. Okay, saying that maybe vaccine is not the only way. Okay, many respected professionals have argued against the response to this. Response political is one thing. Response medical, like creating the vaccines. Yeah, I guess you'll find that there are a lot of doctors out there that maybe are suspicious or a little skeptical about vaccines. Okay, I don't think the majority of them are. I think the majority, I would say at least 90%, are in favor of vaccines, and they believe in vaccines, that vaccines will do something for you. There could be a percentage, I would say at most 10%, that do not accept vaccines or do not believe in vaccines. Maybe they're holistic doctors, if you can call them doctors. Okay, I mean, a guy who runs around the fire, you can say, well, he's a doctor, he's a witch doctor. Maybe makes it rain, I don't know. And so there's been so much fear mongering and lies. Yeah, that is true. And so again, I covered that the other day, saying that uh, some people take advantage, or lots of people take advantage. They're trying to make a buck out of this, including the big corporations that sell the medicines and so on. Doctors themselves, maybe, my brother died this year, and he died of diabetes, and I would doubt it for a minute if the hospital told the government that he died of COVID, because they get money for people who die of COVID. They don't get money for people who die of diabetes. So I would think that maybe, just maybe, you know, uh, they're making money off of this. Lots of people making money off of this. Okay, another issue. Person says, have you taken into account all of the side effects from the vaccine? Or how about what the heck is in them? Yeah, again, I got the vaccine only because I'm going to be traveling. I got my second shot, I guess, 23rd of September, I think it is. And, I got it not because of health reasons. I didn't get it for a year and a half. I mean, I didn't care. And I still don't care. I'm not worried at all about my catching the virus. And the way I look at it, if I catch the virus and it does get me and I don't have any natural defenses, I die. That's it. That's how simple it is. Okay. Of course, a 20-year-old has a different perspective than I do. I'm going on 70 here, so we all have different situations. But I'm not concerned at all about this vaccine or the COVID. I don't even think about it. I don't lose any sleep over it. But again, you have people out there who have to deal a lot with the public, and they have, in their jobs and so on. And so they're in a different situation than a fellow who stays at home or has home office, okay, or is unemployed. And those people, a lot of those people have enough time to create a lot of these conspiracy theories about the Illuminati and all that stuff. Yeah, it's a different story when you have to work with a lot of people. A lot of those people, a lot of those workers are worried that they're going to see, they're going to come in contact with with the masses, and they have a higher chance of catching the virus if there is a virus out there, right? And so they try to get that shot in the arm, okay? And they say, well, just in case I'm going to get my shot. There's a lot of jobs that even are requiring it, demanding that you have the vaccine, otherwise they won't let you work. And so, there's a lot of these situations out there. Everybody's got a different situation. My situation, I'm going to travel. That's the only situation. I don't want the hassle. I've already went to Iceland, in May, and they gave me a little bit of a hard time. I don't want to go through that again. Especially coming back to Germany here. If you come from a fourth world nation that's on the list, like the United States, for example, then they put you in quarantine. Okay, In fact, I think it's Holland, I heard, or Sweden. One of those countries won't accept Americans right now. So, yeah, with vaccines or not, I guess. Okay, fellow says, I also got the shots. I swear many anti-vaxxers have done too, but won't admit it. Yeah, we have all kinds of situations out there, people who are lying. You know, the world is a very complex place. Okay, let's get on with the issue today. And what's the issue? Well, the issue is we're going to try, this is the second installment. I'll be talking about transparency and opacity, why objects or substances are either transparent or not transparent, opaque. Okay. The other day I mentioned one clue that Mother Nature gives us, and it goes more or less like this. Okay, we did a little experiment with my wife. Okay, and shown a laser through two lenses that are polarized lenses, and you can see all she does is turn them around, and just by turning around the lens, the beam disappears. Okay, so what I'm saying is that what you got here is one clue that Mother Nature gives us. Okay, that maybe it's the alignment of molecules or atoms, whichever one you want there, that is producing this effect. We're turning something which is transparent into something that is opaque. Okay? That's the idea behind polarization. Now, one fellow out there says, question that, and he says, polarization has absolutely nothing to do with materials being transparent. Okay. And so he says transparency is caused by the transmission of light. And again, I showed already in a couple videos, last couple videos, that we're not transmitting anything. Nothing is going through the wall. Okay, it doesn't matter if the wall is of cement, bricks, or whatever, or if it's air, water, or glass. The light does not go through walls. Okay. It doesn't matter what wall you want, okay? And what I'm saying is you have every material out there, every substance out there is made out of atoms, molecules, okay? And light does not go through molecules. Light does not go through atoms, okay? Even though, as the religion of quantum holds, and they say an atom is mostly empty space. Well, if that were so, then, you know, light should go through everything. Okay? And that's when they come up with all these attempts at explanations, which is what we're going to be debunking here in this session and ones that come after this. Okay, so this fellow continues, says, transparency and opacity of objects depends on how light waves interact with the materials of those objects. Well, we can't talk about light waves. There's no such thing as a wave. Okay, there's a wave. And what you're seeing there is a bunch of vectors that are moving. Okay, what is a vector? It's just magnitude and direction. So for this fellow to talk about waves in the 21st century, you know, I mean, he's outdated. He should stay in the 19th century. There is no such thing as a wave. Okay. Maxwell came up, one of the guys, the other one was Fresnel, they came up with a transverse wave. And what is a transverse wave? Just a bunch of vectors, moving vectors. That's math. We don't have a physical object in front of us still at this point. And if you're strong about waves, you got to tell us what that wave is. What is that wave? Is it what I'm showing there, a bunch of vectors? If it's not a bunch of vectors, tell us what it is. Tell us what it's made out of, you know, whatever. Okay. So yeah, this is a problem. People use the word wave. And so let's go one by one here. Here you have waves. I covered this the other day. Air waves, you can see that the particles of air don't move from A to B to the ear. Okay. What happens is the molecules which are close to the ear are banging against the ear. Okay, so you're shaking all the air that's in the room when you hear me, okay? And it's those molecules which are close to your ear which are making you hear. It's not the molecules that I'm vibrating here that are reaching your ear. That's my point, okay? Same with water waves. Water waves, you see there are a couple blue ones in the center, and they're just moving locally, okay? So even if you're going to use waves, okay, waves don't move like you see there on the bottom left. They're not like those vectors that are moving over. If anything, if light is made of waves, or gravity is made of waves, it should be local like you see there with the air waves and water waves. Why would Mother Nature do something different for light? Okay. Okay, let me get rid of this. And then here's another aspect of it. Maybe what this fellow is looking at, or think he's staring at, he's thinking it's waves, but maybe it's a rope. Okay. So maybe this notion that people have that there's waves moving from left to right, maybe nothing is moving. Maybe all we have is a rope that is twirling in place that gives the appearance of a moving wave. Okay? So again, you can't use the word wave until you identify what the object is. Wave is not a physical object. Okay? And then we go to a definition of what transparent is, because this fellow questioned whether polarization has anything to do with transparency or opacity. So we have to look at the definitions here, okay, and find out if polarization qualifies. And here you see two sources. Put one the dictionary.com, the other one the Wikipedia. Okay, and you can look up others. I'm sure you'll find exactly the same thing. You can go to the Oxford Dictionary or whatever. Okay, transparency or transparent. What is that? Having the property of transmitting rays of light through the substance. Okay, but it's the only one that mentions what you see there after that. It says, so that bodies situated beyond or behind can be distinctly seen. The problem with the word seen there has to do with observers, making it subjective. I mean, if we put a blind man and he can't see, he says, well, it's opaque to me. Well, no kidding. Okay, so this seeing thing is something that, whether that has anything to do with transparency. Okay, but we'll get to that in a second. What is opaque? Well, it doesn't mention anything about seeing. It just says impenetrable to the light, not allowing light to pass through, which is exactly the opposite of transparent, meaning that transparent is just when it allows light to go through, not necessarily seen. Okay, and again, it shows that the mathematicians never define words scientifically, and that's why we get into these problems. We get into these problems because we don't know if we're talking about an objective criterion, meaning whether light goes through something. Whether you're blind or not, the light will go through a polarizer, or not, depending on what direction they are. And so it doesn't matter if you're blind or not, because what's happening to the polarizers is independent of opinions. On the other hand, whether you can see something or not, that introduces an observer into the definition. And of course, a mathematician is a person who can't tell the difference between these things. That's why they don't have any rational definitions in mathematical physics. Okay? And Wikipedia, again, doesn't even mention the seen, the observer. It just says the physical property of allowing light to pass through the material. That's what everybody understands for transparent. And what is opacity? The opposite. The measures of impenetrability to electromagnetic or other kinds of radiation, especially visible light. No notion whatsoever whether you can see or not. Okay, so this see thingy is the one that you got to question. Okay, but let's introduce it. What the hell? Let's put it in there. Okay, let's make sure we cover all the bases. Let's accept observers. Okay, if you have two polarizing lenses and you shine a light through, and you're on the other side. Okay, you're on the other side of the two lenses. Well, at one point, the laser hits your eye and you see it. Maybe you go blind. And on the other, it doesn't. Okay, so even if you were going to put the observer into polarization, it fits the definition of transparency and opacity. From the screen's point of view, which is the observer's point of view, which is the opposite end of the laser, right? You either see it, meaning it's transparent, or you don't see it, meaning it's opaque. Okay, so yes, polarization does have something to do with transparency and opacity first, and second, it's one of the clues that Mother Nature gives us as to why some objects are transparent, others are opaque. But to prevent, to get ahead of people out there, it's not the only mechanism. People say, oh, it's not the only mechanism. Let me cover the other mechanism. Allow me a chance to cover the other mechanisms before you open your big fat mouths. Okay? And this is the problem. People say, oh, but how about this and how about that? Well, let me get there. Okay? And that's why I'm taking it one installment at a time. Today's the second installment. The other day it was polarization. It gives us one clue. Today we're going to look at another clue. Okay? If you bear with me. Okay, so let's first make sure one more time that we get rid of the mathematical method, because we're not going to find out how Mother Nature does her stuff with this so-called method that comes from the 17th century. So I'm going to repeat this. You can go take a coffee break and then come back if you've already heard it, but I got to go through this for people who are new to the site. We don't follow the mathematical method here. Okay? We follow the scientific method here. What is the mathematical method? It's the one that's covered in high school and college. Okay? And we have a paradigm shift, and the paradigm shift that says that science is not all this other stuff that they taught you. Science is explanations. What is science not? Well, it's none of these. It's not observation. We don't do observing. We don't gawk in science. We don't look without understanding. Okay, so we don't just say, oh, observe, I observed. That's the first step of the scientific method. No. The fact that you observed doesn't mean that you processed and did something with your observation. We don't do predictions. Okay, science is not about the future. Science is about the past. Okay, we do mass extinctions, not the day that humans will die. Okay, among others. Okay, so we don't do predictions. That's astrology. We don't do experiments. In science, we do not do experiments. You heard it here, okay? And no, I'm not drunk. In science, we do not do experiments. Okay? It's in religion where they do experiments. In science, what we do is explain experiments. Okay? There's a difference between doing an experiment, repeatable and otherwise, and explaining it. You have to explain why, what happened, how it happened, okay, in physics. Okay, so doing an experiment is not saying, here, I do an experiment every day, all the time. I let go of the pen, and it falls to the ground. Repeatable, let's do it again. There, we let go of the pencil, and it falls to the ground. So I did the experiment. I'm a scientist because I did an experiment. Okay, so doing experiments is not science. It's explaining them that has something to do with science. Okay, and the problem here is that people introduce observation, prediction, and experiments, and they say, oh, we're scientists. I don't think so. Okay, what's the purpose of experiments? Is to create evidence. What's the purpose of evidence? Is it to get your Nobel Prize? The purpose of evidence is to convince the jury. Okay, that's what evidence is for. It's to persuade, convince, convert, and recruit. That's the purpose of evidence. So we don't use evidence. That's religion. Okay? We don't present evidence of the existence of God, for example. Okay, that's not science. Okay, so we don't do any of these things. We don't do measurement. We don't do description. Why? Because it's mathematical descriptions, just an equation. That doesn't tell me how something happened, why it happened, the cause, the mechanism. Okay, so we don't do measurement or math of any kind. Math has nothing to do with science. Math is not the language of science. Math is not the language of physics. The language of physics is illustration. I need to see the mechanism. I want you to make a movie of the mechanism. It's called illustration. That's the language of physics. Okay, for that you need objects. And for that you need to define what an object is for the purposes of physics. Okay, we don't pay attention to credentials. We don't care if you got a PhD, especially if you got a PhD out of Cambridge or Harvard in mathematical physics, for sure. It's worthless. They gypped you. You should ask for your money back. Okay, we don't vote for theories. No democracy in science. And we don't win prizes. Science is not a beauty contest or the Olympics. You know, we don't get medals for running faster or anything like that, for having more knowledge or king of knowledge. No such thing in science. And of course, we don't censor like they do in mathematical physics, especially physical interpretations. We don't censor those from anyone. On the contrary, we want to hear them. We want to hear as many physical interpretations that you can come up with. No math, no equations, no experiments. Just the facts, like the policeman. Just the facts, ma'am. Just the facts. And what we want, as far as facts are concerned, we're talking about explanation. We want you to tell us a mechanism. You don't have a mechanism. You're not a scientist. You're not a physicist. Okay. Okay. So what do these mathematicians use? Well, for the last 400 years, at least. For more than that, they've been using particles. But for the last 400 years, they've been using these two, the particles and transverse waves. What's the problem? Well, the first problem is that the particles ain't particles. Okay, quantum does not use particles, corpuscles, little beads or tiny grains of dust. No, what quantum uses are concepts, mathematical concepts that they converted into particles, or they represent with particles. That's the first problem. So there is no physical object when they talk about particles. So they chose this word particles, which is very misleading for the common people, because common people say, okay, I know what a particle is. It's only when you press them and say, well, what do you mean by particle? Do you mean like a little corpuscle? And that's when they explain, well, no, you got to take 10 years of math to know what a particle is. That's the way they put it, okay? Transverse wave, I just covered it. No such thing as a transverse wave. All you're staring at is a bunch of moving vectors. So if you're going to go with mathematical physics, they don't have a physical object. They don't have particles, and they don't have transverse wave. We don't have nothing, okay? So this is the problem. So they can't give you a physical interpretation with abstract concepts. Okay, it's important to keep this in mind, okay, because a lot of people use these words, waves and particles, to give a physical interpretation, and unless you know, you understand, you are conscious of the fact that there are no such things as particles and waves, you know, you're going to swallow whatever they feed you. But once you understand that there are no particles and waves, then what you're hearing from these mathematical physicists is bunk, is garbage, plain and simple, okay, because they don't have a physical interpretation, okay. And so here we go. Here are some of the YouTubers that try to explain opacity and transparency, and they're going to use the particle and the wave. Okay, here you have a whole bunch of them, you know, and here you go in there, just look up why is glass transparent, or why is water transparent, or anything related to these subjects, opacity and transparency. You're going to have all these individuals tell you the party line. They're gonna, you know, they're just gonna recite what they learned in college, essentially. Okay, and you can look them up in YouTube. You'll find all these folks. The problem is that you don't need to see all these fellows. Okay, you look at one, you've seen them all, because they all say exactly the same thing, and each one starts the same way. They say, if you go to other sites, they'll tell you something that's wrong. Let me tell you the right way. And he tells you the same thing the other guy told you. Okay, so what is the right way? What is the official way of regarding transparency and regarding opacity? Well, here's one fellow. I've talked about him in the past, Mr. Curley. Okay, and what does Curley tell us? Okay, well, he's got his site, and he tells us the following. He starts with his atom. Okay, and you talk about irrationality. Here it goes. Okay, atoms are mostly empty space. Okay, doesn't look like much to work with. Okay, an atom is mostly empty space. Okay, now the next part is what really shows you how irrational quantum mechanics is. Look at this. It says electrons do not have size. Yeah. Heard it like he said it like that exactly. Okay, these are verbatim. Okay, electrons do not have size. They're point particles. Well, I don't know what a point particle is, but a point, if you put a little dot with your pencil, you have something there. And this guy says it's not even that. It's nothing. It does not have any size, no radius, no diameter, no nothing. You're talking, what doesn't have size? Nothing. That's what has no size. It's called nothing. Okay, so he starts out like that. Then he says something even weird. He says, electrons are simultaneously everywhere. Here you have these are his words, okay? I'm not putting them in his mouth. You can look up his video, okay? And it says electrons are simultaneously everywhere. So you have something that has no size, but it's everywhere. Covers the entire universe. Okay, that's, I cannot even imagine what he's talking about at this point. And then he gives, the final cherry on the cake, says electrons can only occupy certain energy levels in an atom, right? So we have something that has no size, which is everywhere, and which occupies only one energy level. Well, that's the end of his presentation right there. I haven't understood anything. Have you? Can you make sense of what he just said? These are his words. And this is a guy who studied at the university. I think he's got a master's at least, probably a PhD, I don't really know. He makes his money, on the internet. And this is what he tells people out there, what he learned by rote in college. And so he just regurgitates it in a language that would be appealing to the general public. Okay, so what is he saying? He's saying electrons do not have size. They're everywhere, but they can occupy, orbitals. They can occupy energy bands or energy levels. Scary stuff. Okay, but let's continue. Let's see if we can find out something about this. Again, you can see there, that's what an atom looks like with the electron rolling around. It looks like nothing, absolutely nothing. So, why does he say this? Well, that's his introduction, because he's going to say, therefore, a photon is going to hit one electron, right? No matter what. Because the electron is everywhere, okay? I thought it was in an energy level, lower energy level, so how can it hit that one? Well, because the electron is everywhere. So no matter where the electron hits, it's going to hit an electron. Where a photon hits, it's going to hit an electron. That's what he's saying. Well, yeah, that's like covering all the bases. I haven't understood anything so far from him. What is he saying? And then it says, electrons will absorb the photon, okay? I don't know if I had something else there. Oh, no matter what. Okay. Right, because the electron is everywhere. And so what the electron does is absorb this photon, this energy, because they use the word photon energy interchangeably. Okay, whatever energy is, we never figured that out. Okay. Okay, so this is how he starts his presentation, introducing his atom. I haven't understood anything, but let's see if we can bear with him, see if we can find out what this is all about. Maybe you learned something today. Maybe, at least in the negative way, right? Okay, so here it is. This is his explanation for opacity and transparency. And I want you to pay close attention now, okay? Because this is the party line. They all say the same thing, by the way, okay? Okay, so here goes. Okay, so this is what Curly says. He says, when a photon comes along, the electron gets excited and jumps to a higher energy level. Okay, so it looks like the electron hits, the photon hits the electron, and because of that boost, that bumping, that collision, the electron gets bumped up to a higher energy level. That's what he's saying. This is a starting point, okay? An electron in a gas molecule releases a photon. Okay, so it receives and releases. Okay, we got it. An electron in a liquid or solid molecule, the other molecules are too close and the electron calms down by releasing that energy to the adjacent molecules. In other words, if the electron absorbs the molecule, the photon, then it's going to use that to shake the other molecules that are elbow to elbow with it. Okay, increases the thermal energy instead of releasing a photon. Okay, so he's saying now it's absorbed, but instead of releasing the photon and releasing this energy, it uses this energy to do some thermal stuff. It's going to shake the atoms and molecules that are next to it. Okay, it's still absorbed by the electron, but immediately rejected. The energy, here's the important part, okay? The energy gap in glass is too big for visible light. Okay, so you have visible light that goes somewhere from the red to the blue, okay? Infrared is a little beyond our capability to see, and ultraviolet is above, our ability to see. Okay, so it is absorbed by the energy, but immediately rejected. The energy gap in glass is too big for visible light. To excite an electron, the photon has to have an energy of at least 138 nanometers. That's UV light. Okay, so UV light is invisible to us, and so if you want to excite that electron, you can't do it with visible light. You need to get to that edge where visible light becomes UV light, higher energy, and at that point, then yes, the electron gets bumped to the higher energy level, and that electron or that atom, that substance, becomes opaque. Okay, so this is the issue. Okay, this is how he's going to explain it. And he says, if visible light cannot excite an electron, it won't get absorbed as thermal energy. It still gets absorbed just as vibrations in the electron instead. And since the electrons reject those photons, they make it out the other side. Okay, so if the photon is not absorbed, it just goes through. And that's where all these people get the idea that light goes through substances. And he says, finally, he says, transparency. He shouts it out like saying, ha, that's how you make transparent things. Okay, so let's see if we understood what Curly said here. Okay, I want people to understand this. Okay, here's a photon. It comes. If it doesn't have the energy, enough energy to bump, to strike that electron and push it to a higher energy level, okay, then that photon goes through essentially, and that's a substance that is transparent. Okay, if instead it hits the electron, well, one of the two, it gets re-emitted, or that electron will translate that into thermal energy and essentially shake the atoms and molecules that are next to it. Okay, and in that case, it's opaque. So opacity turns it into thermal energy at best, or just absorbs it. And in the case of transparency, the photon is not strong enough, not powerful enough, not energetic enough to boost it to a higher level. Okay, we got that? It's important for you to get it. I know some people will want to rush through, but I need to make sure everybody understands it, okay? Because we got a punchline for all these people. Okay, and just in case, want to make sure that this is the party line. It's everywhere. Here you have the same thing from Quora, okay? And a fellow says, why is glass transparent? Okay, dense materials like glass or lead are almost entirely empty space. Great, so everything should be transparent, right? The air and water in the glass are almost entirely empty space. Good, so light should just go through, right? The little photon, the little wave or whatever. The primary reason glass is clear is because it has a large band gap. Aha, so we have a difference in energy levels, right? And here's the electron at the lower energy level, and there's a big gap for it to jump to the next energy level. This is the idea, okay? The large band gap is important for transparency because one of the main ways light can be affected by matter is when an electron absorbs a photon. We're going to absorb that photon again, okay? The electron jumps to a higher energy level. You got that? Okay? Higher energy level. And the photon disappears. Okay? So it's absorbed, it's opaque. Okay? The electrons at the bottom of the band gap can only absorb if the photon gives them enough energy. So if it's weak, doesn't have the energy, okay? It doesn't have the oomph to push that electron to the next energy level. That's what they're saying, okay? So they're all saying the same thing. Keep that in mind. They're all saying the same thing. They all went to the same school, okay? That is only photons whose energy is larger, okay? It's got to be mightier, okay? Then the size of the band gap can be absorbed. We got that? Okay? I hope everybody is tuned in and understands what I just said, okay? And I'm going to rub one more in there, okay, before we move on to explaining all this stuff, okay? Here's the mechanism. I've illustrated it so that you have no doubts, okay? They're saying here comes the electron. You'll see it in a second here. Hits the photon and hits the electron jumps to a higher energy level. This is essentially what they're saying, okay? And so if it jumps to a higher energy level, it absorbs the photon, therefore you don't see, that photon doesn't get to your eyes. If on the other hand, you know, the electron does not absorb the photon, then that photon reaches your eye, okay? So that's the theory. We all got it? I hope everybody got it, okay? Is there something wrong with this? Let's find out. We'll let Mr. Bean show us why something is wrong with this theory, this explanation. Here's Mr. Bean, okay? And he's in a one-way mirror, okay? So he thinks he's in front of the mirror, but the people on the other side, looking through the same piece of glass, okay? Same thickness, same material, they can see right through the glass. They can see him, but he can't see them. So if I were to shine a laser, okay, from one end or from the other, we would have a different result. It's same material, same glass, okay? You can say what's coated here, whatever, the light is different here. Yeah, I don't care about any of that because we're talking about the material. Here we're talking about the photon from a laser, okay, hitting, being absorbed or not absorbed by the same material from one end or the other end, okay? And so the glass is the same in both cases, whether you're on one side or the other. If I shine a laser from one side, I should be able to see through it. And if I shine it from the other side, I'm going to get a reflection. So we got a problem with this notion that the electron absorbs the photon, because here this is not the case. It absorbs it in one case and not in the other. Okay? But we're not going to stop there. We want to make sure we trash quantum mechanics completely. Okay? So let's make sure we do away with the this theory that quantum mechanics has of absorbing photons. Okay? And here you have a situation, very simple. Okay? And here we have glass, which is opaque. And how did we make this glass? Well, we originally started with a very thin sheet, which is transparent. And the more glasses we put in there, the greener it becomes. Okay, it becomes opaque at some point. If you make glass very, very thick, it's completely opaque. It's only very thin glass that we use like for windows and so on, window panes, that are transparent. Okay, the more glass you put, the darker that glass becomes. Okay, and so let me show you this. Where is it? Okay, you can see it there that if you put one glass on top of the other, it gets darker and darker and darker. At some point, it becomes opaque. Okay, so what happened here? If this is an issue of the photon being absorbed or not absorbed, are we seeing that the more glasses we put, the photon gains energy until it's finally absorbed by an electron, which jumps to the higher energy level? how did that photon gain energy as it went through thicker and thicker glass? You would think it's the opposite. If anything, it loses energy. I mean, you would think, right? But assuming all else being equal, here we have a photon that was not absorbed, but at some point it gets absorbed because you don't see the photon coming out of the other side. Light does not get through that thick glass. It's opaque. And what do they say? The reason for that is that the electron absorbed that photon. And the only way it could do so is if the photon has sufficient energy to boost it to a higher energy level. Okay? So here we have this photon. It's got the same energy that came from the sun, right? From your flashlight or whatever. Okay? And it goes through the first glass, no problem. No big deal. But as it tries to go deeper and deeper and deeper through that whole glass, at some point it gets absorbed and it doesn't get to your eye, which is on the other side. But for that, according to quantum, you need more energy. How did the photon gain more energy? By going through thicker glass. Okay? So that's the first problem we got there. And so I ran an experiment, and it goes like this. This is a transparent piece of plastic. Okay, some material. I don't even know what it is. I don't care. You can see my nose, you can see my mouth, okay? What happens if I put a stack of these? Okay? Can you see my nose and my mouth now? Okay, so one sheet, no problem. Semi-transparent, you could say, almost transparent. Many sheets, not transparent. So what happened to this photon? And it's got trouble getting through. It was absorbed by the electron simply because of the thickness of the layer in front of it. You see the problem? And just in case, did a little experiment. Okay, goes something like this. We have a candle there, and I'm going to put a single sheet of these, and you can see the light of the candle through it. Okay, it's got all these little lines, fine. But when we put the whole stack, you can barely see it, and the more of those sheets that you put, you won't see it at all. You won't see the fire at all. You won't see the light on the candle. Okay, so this is one sheet. Okay, and here are many sheets. Is there a difference? Yeah, of course there is a difference. And what was the reason? Well, the reason has to do simply with putting more in there. More sheets. So we have all these transparent films. The more of these transparent films you put, at some point it becomes opaque. Now, isn't that a magic trick? Take all the transparencies. So the addition of transparent material gives you opaque. Okay? We got that? Okay, here's just in case I did it with a laser. Okay, I pointed the laser at many of these sheets and it doesn't go through. But when I point the laser at one sheet, okay, just confirming here, see, there's one sheet and you can see it goes right through. Okay, so just want to make sure that we're all on top of that, okay, that we all understand that putting many of these transparent films, you can create opacity. So how does the quantum explanation fit into that? Here we have the photon. It's got to gain energy to boost the electron to a higher level. And these people are essentially saying that this electron going through more films gained more energy, enough to boost that last electron to a higher energy level, and that's why the film is transparent, is opaque. Yeah, sure. Okay. And here's another experiment for you to do at home. Okay, this is a very expensive experiment. I don't know if it's within your budget. Okay, and always do it in the presence of a relativist. Never do it alone. Okay, and it goes like this: you get two pieces of tape. The only difference between these two pieces of tape is the thickness of the tape. Okay, I want you to understand that. Okay, The difference is just the thickness. That's it. This one is almost gone. I need to buy a new one. Okay, and this is almost full. Now I want you to see here on this one. Okay, let me show you this. See, you can see the line right through the tape. The tape is transparent. You can see the cardboard line there where the cardboard has been rolled around. See, that's that cardboard inside there, and it's been. You can see it. You can see it right through the tape. This one you cannot see it no matter how you turn it. Okay, so here I'm turning it around, and you can't see the lines no matter what. So even though this is transparent tape and this is transparent tape, bunch of these make it opaque. One of these, or very few of these, make it transparent. Okay, many against the few. Okay, so now we have learned a second way that Mother Nature does opacity versus transparency, and it has to do with how many layers we put in there. One layer, transparent. Many layers, not transparent anymore. And that debunks the nonsense that quantum mechanics says that it's got to do with the absorption of photons by electrons. They would have to explain why that last electron finally absorbed, or one of the atoms in there, one of the electrons in there absorbed that photon. Okay, why? How is it that by making it thicker, what's that got to do with an electron absorbing a photon and jumping to a higher energy level? By making it thicker, did the photon gain energy? Is that what they're saying? Okay, so here are the conclusions for today. Okay, and it goes something like this. First clue I talked about the other day, Mother Nature does transparency, opacity in polarization. So polarization is one of the clues Mother Nature is giving us on how she does transparency and opacity. Okay, if the films are aligned, you have transparency. If the films are not aligned, one is, in this case, 90 degrees to another, then you have opacity. And so I asked the following. You can't see through your brick wall, but the question is, if you had the power of God and could align every atom in the brick, everyone is so perfectly aligned in some way, some fashion, would you be able to see through the wall? Because again, light does not go through atoms, through any kind of wall, whether air, water, or glass, or cement. Water is relayed from one atom to another. Okay? And so if we could align every atom in a brick or in the cement or whatever, would you be able to see through your brick wall? That's the question. Okay? Does it have to do with alignment? Well, at least in one circumstance or one situation it does, and that's polarization. By merely rotating or misaligning, right? Atoms, molecules, we can produce transparency or opacity. Okay, so that is one clue. Mathematical method, irrational. Okay, you can't follow that to explain, for example, opacity and transparency. Irrational, what is it? To simulate physical interpretation with transverse waves or 0D point particles, which is what quantum mechanics proposes. What does classical mechanics propose? Okay, we're talking about 19th centuriers here, people like James Maxwell and so on. What did they propose? Well, they said, discrete corpuscles. But the problem with discrete corpuscles and waves, which is what he really proposed, right? But they were all thinking in terms of particles and waves all the time, okay? You can't simulate the properties of light. You can't do it with discrete particles. You can't do it with waves because there's no such thing as a wave. And you can't do it with zero-dimensional particles, which is what quantum proposes. And so that's the end of those physical interpretations. You can't explain with whatever they propose to date. Okay, and so quantum theory that 0D photons, such as 0D, push 0D electrons to a higher energy levels or bands is debunked. Okay, it's bunk. Okay, and all we have to do is just put more layers of whatever substance, and we show that it's got nothing to do, in those cases at least, right? Again, we're explaining the second version here, the second installment. In those experiments, those situations, you cannot explain with this absorption of a photon by an electron. Okay? And so, yeah, that's the second clue of Mother Nature, that she does transparency opacity by changing the thickness. Okay, so that's the installment for today. Okay, let's get to the questions that people asked, comments. Here's the first one. Sorry, can you tell everyone the definition of shape again? You said shape is what distinguishes the inside of an object from the outside of it, and we can treat both the inside and outside as objects. Then you said shape is the inability to blend with the immediate surrounding or environment. Well, I already answered that question like twice already, but this guy is not picking up on that. But okay, I'll answer it one more time. Okay, hopefully the last time, so I don't want to bore the crowd out there. Okay, so here's the problem with this fellow saying. Okay, these are the words that define the word object. That which has shape. There's just 4 words there. Okay, so here's the first question to him. I'll answer with a question. Why didn't he ask me to define the word that? How about the word which or has? I mean, are those words easier to define than the word shape? Okay, so that's the first issue. Why did he pick on the word shape? Doesn't he? I mean, I'm sure he can tell me easier what the word shape means and be able to define what the word that or which mean. Okay, those are much harder to define. Okay, so that's the first issue. Here, let's go to the second issue. Here it goes. Okay, and that's that in science we don't define every word in the dictionary. Okay, so you can't just continue saying, well, how do you define that? And so you define the word that and say, well, this is how we define the word that. And you go through all these words and they say, well, how do you define and? And how do you define or? How about the period? What do you mean by period? We don't go through all that. We don't define words just to please the devil's advocate. Okay, we define the words that we're going to use to explain a mechanism, the crucial words that are necessary to explain a phenomenon, how something works. And for that, and for the rest of the presentation, we use ordinary speech. Okay, just normal understanding of words. If there's a critical word that you don't understand, I say in. You say, well, what do you mean by in? Well, I mean in, you know, like the dog went in the house or into the house or whatever, you know. So do I have to explain what in means and so on? How many words do you want me to explain? Every one of them? I'm going to spend the whole day explaining every word in the dictionary? Is that what science is about? Is that what physics is about? No, we're trying to understand the mechanism. Okay? And in this case, we define the word object as that which has shape. And the purpose of that is to distinguish it from what the mathematicians do, which is saying that it's see or touch. So we have to choose a criterion or criteria for defining the word object. Are we going to choose shape or are we going to choose see, touch? That's the entire issue. You can't say, well, since you couldn't define shape, I'm going back to see and touch. That's what we want to avoid. See and touch are verbs. Verbs are preceded by objects, so you can't use a verb to define the word object. And more than that, see and touch require an experiment and also require 2 objects. Only something, if you see something, there's 2 objects in the field of view, in the movie. And if you touch something, there's 2 objects in your movie already. Okay, so you got a problem. Okay, science defines only those terms that make or break a theory. Shape is not a key word. We don't define the word shape because it's not a key word. People who harp on the word shape are mentally retarded individuals who think they're smart, okay? And all they do is show their ignorance because, again, all we're trying to do is compare the word shape against see and touch, which are the current parameters or words that are used to define the word object. Okay, shape is an adjective. Okay, that's what it is. Say, no, it's a noun. Well, that's in ordinary speech. In physics, shape is an adjective. It qualifies a noun. What is a noun? Only objects can serve as noun, and nouns as fit in physics. Okay, we can't use the word motion or the word orbit as a noun in physics. Those are verbs for the purposes of physics. And so physics has a different language. That's what this site is about. It debunks all the nonsense from mathematical physics, which has introduced words of ordinary speech like orbit and motion and orbital, for example, and turned them into nouns, into physical objects. Brought in wave. It says a vortex. It calls plasma a thing. Those are not things for the purposes of physics. Okay, it takes a long time for someone to learn the language of physics. Okay, so shape is a property of objects. Shape merely describes, okay, and science is about explaining. Okay, so there you have your answer. Hopefully this time the fellow reads it or sees it or whatever, because he's asked this question like 2 or 3 times now. Okay, go with the next question here. Comment. Fellow says, the mathematical method. And he goes through it. He says the mathematicians made up the mathematician method. Yeah, correct. Okay, you got that one right. The mathematician method has 5 basic steps plus 1 feedback step. Okay. Make an observation, ask a question, form a hypothesis or testable explanation, make a prediction, test the prediction, and then do it all over again. Yeah, that is the ridiculous mathematical method. Okay. What is an accepted mathematician's method is a requirement for any kind of mathematics. Well, I don't know if they'll agree with you on that. Okay, I think math is an important part of the mathematical method. And what is involved in accepted mathematician's method is experiment, observation, and prediction. Yeah, correct. That's what they use in the mathematical method. But we do science a little differently. Okay, science is a little different. And here you see the problems with the 17th century so-called scientific method, which is really the mathematical method. Okay, and this is why it's unscientific. First of all, it has statements of authority. Okay, they turn all these opinions into facts. Then they have unjustified opinions and beliefs, which is religion. That's what this leads to. Okay. Tradition, they say, well, we always done it like that, so we're not going to change now. And then we have democracy on top of that. Everybody does it this way, and that's how we're going to continue doing it. Well, none of that has anything to do with science. In science, you have to get in the ring and fight for your definitions, for your theories, okay, for everything that you propose. And these people want to do it on the basis of tradition. Says, well, this is how I learned it in college. I learned it from the previous generation. Who learned it from the previous generation? And we're just going to keep it that way. That's not science. That sounds like religion. Okay. And so this mathematical method, when we apply it, it has led to irrational explanations. And here are a couple examples. Gravity is supposedly the warp concept known as space-time. You warp a concept, and that's gravity, and that's why the pen falls to the floor. Then you have a particle can be at 2 places at once. That's a quantum thingy. Okay, how can a particle be at 2 places at once? What sense does that make? Is that what this scientific revolution created after so many 400 years? Then they ended up with a planetary model, Big Bang creationism, and they say that there's something called a black hole, which is a zero-dimensional, yeah, you heard it right, zero-dimensional singularity which moves stars around. How do you move a star with a zero-dimensional nothing? It's like that photon. All these are singularities. Okay, you have the photon is zero-dimensional, no size. The singularity that's at the center of the black hole is zero-dimensional, no size. And this creates an event horizon, which is a concept. Okay, it's like the heat of a campfire. Okay, and that's how they move stars around. Oh yeah, only after the 4th beer. Okay. Okay, so yeah, that mathematical method has nothing to do with science. It's got to do strictly with religion. Okay, somebody said you have to be retard, okay, to think reflections come off the surface of water. The comment is correct, this fellow says. We can see very clear reflection off the mirror inside the water, okay? And we did an experiment with Hans, my son, and what we did, we put a mirror in a trash can, the bottom of the trash can, okay? And then we poured water, as you can see there, we're going to be pouring water in there, and we can still see the mirror throughout. At all points in time, we see the mirror in there. And this guy's saying, well, you can see, I don't know what he's trying to say there because he didn't explain it in any detail, okay? But there you can see the mirror at the bottom of the pool, and we're seeing that through a bunch of water, okay? And so this is the issue. People will think that they get their reflection from the surface of the water. That's the standard explanation out there, okay? Do you get some reflection from the surface? Yeah. But you throw a little coin at the bottom of the pool, okay? And you can see it through several feet of water. You see the coin down there. And what this person's arguing, he says, well, you're seeing really the reflection of the from the top, from the surface of the water. So here's the million-dollar question for you. How did the light from the coin get to the surface of the water? I'll grant that, okay, so I see the reflection from the surface of the water. Fine. If I cover the coin down there with something, will I still see the reflection out there from the surface of the water? So somehow the light from the coin got to the surface of the water. So when I'm staring at the coin, like we just showed there, I'm staring at it through the water all the way to the bottom. Okay, and if, as we say, light does not go through atoms, through any kind of wall, whether it be air or water or glass, it's relayed, okay, at the speed of light from one atom to another, okay, goes all the way down there and comes back along the same channel, more or less, unless the water moved a little bit. But if the water's stationary, if we could keep it there, right, then it would be almost a straight line back and forth because it travels at the speed of light. Okay, that's the signal, the torsion. Okay. Okay, so yeah, no, we don't see it only from the surface. You do see some reflection from the surface. Okay, there is reflection from glass. There is reflection from water. There's even reflection from air, whether you believe it or not. There's reflection from normal air. That's why air has a refractive index, a very small refractive index, but air is not completely transparent like empty space. Okay, so yeah, there is some reflection from surfaces, but you still are looking at light that came from the coin at the bottom of the pool to the surface of the water. Okay, next issue. Fellow says, a second here. Says, for the sake of simplicity, let's say there is only one atom in your laser pointer. So we have a laser pointer here. Okay, laser pointer. And says there's only one atom. Okay. This atom is the source of the rope pumping. Okay, so remember the atom is pumping. It's not the rope. It's the atom that's pumping. It's torquing the rope. Okay, and of course this atom is connected by a rope with the receiving atom on the moon. So yeah, so you have an atom here on the Earth, part of a laser. We're going to shine it at the retroreflector on the moon. That's what he's referring to. We get a signal back. Okay, that's the laser ranging experiment NASA and Russia are doing, or are still doing. I think there's 5 of them out there in the moon. Okay, for those of you who are not flat earthers. Now you point your laser in another direction to another atom, of course, also connected with a source atom. Okay, how does a source atom know what rope should it starts to pump? In other words, he's saying if I have a laser pointed in your direction, right? And he's talking about a single atom. This is the issue here. He's talking about a single atom. If I point it in a different direction, that atom is pumping in all directions radially. So he's saying, why do I see the laser going in one direction and not in all directions? That's his issue, okay? If it pumps the ropes to all atoms in the universe, okay, to which it is connected, it must be one mighty pumper. Okay, yeah, all atoms are mighty pumpers. They all pump to every atom in the universe. But it still doesn't explain why only some atoms in the general direction to where your laser pointer is pointing can feel the rope torquing. And he's talking about the frequency, saying, well, here you have a high frequency. I only see it in one direction. I don't see it in all directions. That's his argument, okay? Okay, so let's understand what he's saying. So it's an important question. Okay, so what do we answer? We say this is from the internet, okay? It's about lasers, and essentially it's our argument. Laser light is directional. You can't do this with one atom because one atom is not directional. One atom is radial in every direction. But what we're going to do here is we're going to reorient light in a given direction. We're going to give it a boost in a given direction, okay, with a laser. Whereas a laser generates a very tight beam, a flashlight produces light that is diffuse. And you can see it here. See, that's diffuse light, and that's laser light. See if I can point to something here. I guess I'll point it to me. Okay, you can see that this one it's just pinpoint. Okay, there. And this one, there it goes. It goes in every direction. So there's a difference between a laser, which is directed, and a regular light, which tends to diverge, okay? Because laser light is coherent, it stays focused for vast distances, even to the moon and back. So that's the short answer, okay? That's the quick answer to your question. Okay, we're talking about directional light, okay? And of course, that needs a little more explanation. All I'm saying is you can't simulate this or can't answer this question using the situation you're proposing, which is a single atom. We have no directional there, whatever that means to you. Now, in order to have directional, you need electricity in the case of laser, and you need to have all those atoms aligned in some way and shooting the laser in a given direction. You orient it there. It's more or less what I did with the accelerators I worked with. They're known as implanters, and we directed atoms along the beam line. Okay, and so yeah, you can do that with gases. You can ionize them, and then you can, with magnets, you can orient them towards a wafer, and so you can have a beam. It's called a beam, and you direct things. Okay, it's not like gas goes everywhere. Fill the gas. Air into a balloon, and that air is everywhere. That's not how you do it you can take that into a beam line and orient it anywhere you want. Okay, another one says, make visible the invisible, the ropes. Well, there, I made it visible. There you see it. Okay, so, and here's another rope, okay? You see it? That's a visible rope. Okay, that's a rope, known as a rope. You don't believe me? You think I'm creating a hoax here? Go to your hardware store and ask for a rope. And 2-strand rope, okay? And they'll sell you something like this. And you'll see that a rope is visible. Yeah, all ropes, as far as I'm concerned, are visible because an object is visible simply because an object is that which has shape. So there should be no reason for you, unless you're blind, not to see it, okay? Okay, but here's the issue. Try to do that now with your quantum particle. What is it? What did these folks say? No size? Zero-dimensional point particle? What does that look like? Please make that one visible. What are you going to put? Whatever you put there is not going to be zero-dimensional, no size. And how about the transverse wave? Well, the transverse wave is made out of electric fields and magnetic fields. Okay, what is a field made out of? Well, it's made out of vectors. What is a vector? Magnitude and direction. Please make visible magnitude and direction. What are you going to put? An arrow? An engine arrow? Is that what you're going to draw for magnitude and direction? So, yeah, try to make visible first the quantum particle, try to make visible the vector, and if you can't make that visible, well, you don't have any physical object. On the other hand, the rope, yeah, there you see it. It's visible. Well, we can make any rope visible. If you have doubts, go to your hardware store, buy yourself a 2-strand rope, and you'll know what we're talking about. Rope is always visible. It's an object. These are not objects. The point particle and the wave, those are not objects. Those are not things. A wave is a verb, and a point particle is a nothing. It's known as empty space. And you don't need the word empty because space is nothing. Okay, here we have another fellow, and he says, I thought they claimed that space was a vacuum, not filled with particles. No, you got that one wrong. Quantum mechanics and general relativity, in fact, all of mathematical physics, believes and holds to this day that space is made of particles. And here you have just 3 examples. I got them from the internet just very quickly. Just go in there and just put the question there and you'll find it from everywhere. In fact, I got one from ABC News, Science News, the other one from Quora. The first one I can't remember. I forgot to put the reference. But it says, first one says, perfectly empty space will always have vacuum energy, whatever energy is, okay? Energy is a concept, but apparently space is filled with this concept. The Higgs field and space-time curvature. Okay, so I hope that makes sense to you because I don't know what they're talking about. What is this energy thingy? Okay, and what is vacuum made of? Let's see if I'm out of focus here. Ooh. Okay, I guess I'm back. Okay, what is a vacuum made of? Okay, and how do they answer? They say the universe appears to be a strange quantum foam. Okay, with virtual particles popping in and out of existence, obeying the laws of quantum mechanics. That's what the vacuum is, just particles that come in and out of the void. And physicists, this Quora physicists are now becoming convinced that empty space is in fact not empty at all. Rather, it may be a void that is filled with a kind of ever-changing static, a sea of something that has been described as cosmic foam, virtual particles of space-time, vacuum energy, quantum strings, or vacuum fields. Strange fields of virtual particles popping into and out of existence inside space. So yeah, the vacuum, the mathematical vacuum is not a physical object in the sense that it's made out of many particles, and that's not the definition of an object. But at the same time, they're saying that space is made of particles, okay? And these particles come into our world by separating between positive and negative, and when they get together, they form a particle which is neutral, I guess. I don't know. Ask them. But yeah, they think space is made of particles, and this is more or less what it looks like. This is the notion they had from the 19th century, where the wave is the waving of the ether. And what is the ether? A bunch of particles. That's what it's always been. Ether means just that space is made out of particles. And those particles are vibrating, and that vibration is what they call light. And relativists extended that to gravity, and so they talk about gravity waves. What is it that's waving? Space. Space-time, the canvas, that's what's waving. That's what prevents the Earth from flying out of the solar system. Okay, but very important. We have to celebrate Rosh Hashanah coming up. So a fellow says, rabbi there says, we celebrate the anniversary of the creation of the entire universe. Okay, and why do I bring this up? Well, I bring this up because a lady there who is a rabbi, and she says, I don't believe in a cosmic God, that if you do this, this will happen. And she was referring to what's happening, or what happened in New York, the flood. And she's saying that that's a little bit of a punishment that God sent us. She doesn't believe this cosmic God, which is in the Talmud, you know, the Pentateuch, first 5 books of the Bible. And there it talks about a cosmic God. She doesn't believe in that God, but at the same time she says we have to pray. Have to pray so that we appease the God. Not the gods, plural, but the God up there, so that he takes pity on us and gets rid of all that water he threw around people. So happy Rosh Hashanah to you, and may your God go with you. We'll see you